in this case, you have to build a training pipeline and you have to build an inference pipeline. Now, you don't need to train that model every single week, or if you do, you don't need to change your training pipeline every single week. I think that's the world, the data science world that we lived in. So, how do you get to that pipeline of training and inference at a speed which was sort of unthinkable pre LLM? I think that's where it has played a big role. And once you have that pipeline, stick to that. I mean, if it works, stick to that. No need to make that pipeline non-deterministic, because that's where people are like, let's have an agent and that agent can figure out what needs to be done. And I'm like, sure.
Great. Welcome, everybody. Today, we are going to talk about agent architecture, and one of the favorite hot topics of token optimization, burning too much, and how to watch for it, and how not to burn your monthly limit in a day or a few hours. Hopefully, you get to the nitty gritties of it. So, Shanti and Anshul, welcome. Let's dive right in. Let's start with architecture. How Anshul, it'll be great if you can give a little bit of background what you guys up to as well, and then kind of think about architecture, agent architecture, and we can touch on harnesses or however you are set up, because I know everybody is set up in a different way. So it'll be great to understand.
Yeah, absolutely. Thanks, Piyanka, for having me. And I could not, yeah, I always enjoyed talking and thinking about agents. So we, just to give you some context of what we do, we are, at the company that I work for, we have it's a retailer. We have a lot of different types of problems, and we are constantly right now trying to figure out like what are the out of all the different business workflows that are out there, how can we augment the human intelligence pieces within that workflow? So there are parts in the workflow where there are some systems that make some decisions, but then something goes wrong, for example, and a human is sort of like required to figure out, okay, what went wrong. Let me, for example, if it's a software engineering bug or something, like an application goes down, an engineer will go down and look at the logs, try to understand and reason with those logs to figure out what went wrong, triaging, and then resolves the issue. So that's like an example of a human intelligence coming in the process mix.
Yeah.
And then how do you potentially leverage a agentic system there or an LLM based system there to either completely take over, or at least at the start, um, amplify or augment that specific team member or human resource. So that's this is like a pretty common pattern of what we are doing.
So reducing man hours is one of your things that you guys are working on.
Absolutely, like driving efficiency. And the thing with that also, which comes naturally, is that if you are working in a time crunch as a human, you are likely going to make some choices which might not be the most optimal choices. So it takes you more time and you are likely to make some mistakes, which is where if you have an agentic layer in the middle, it saves you time and also gives you some more time to do additional critical thinking, right?
Yeah.
Like whether this, yeah.
So give these drudgery to AI and do more strategic thinking, which is a
Yeah.
pretty big use case for all workflows.
Mhm.
Great. So that's the basis.
Yep, and we are doing this across multiple business units, and there's a lot of like talk about, oh, we want to transform everything so that it runs on AI and everything else. It's good. I think it's a good strong vision to have. I think that the fundamentals need to be built first before we can talk about running. Basically like being AI first is one thing, and running on AI is a different thing.
Yeah.
I think thinking about how can you improve and streamline is great, but maybe a lot of it requires not using LLM systems. A lot of it just requires building some, basic APIs or some standard ML models, which people just don't think about as much as they should, I think, which is what leads to some token running running out of quota as well.
It's like you want some deterministic output sometimes, and not just whatever a model feels like telling you, because these words should follow after each other most of the time.
Yeah, not only that, I think, Shanti, I think what Anshul probably was alluding to was also saying that with the advent of this whole LLM and people equating AI to LLM, a lot of us with a toolkit of larger body of these models, still probabilistic, Shanti, right? Like our gradient boosted tree is still a probabilistic model. It's not deterministic, but it's a different use case altogether. And it's really strong in the applications, but people in general understand AI to be only LLM. So there is this whole, kind of missing the entire use cases around pure play data science and machine learning, which we all grew up in, uh, and favoring just use LLM. Ask actually LLM to build a churn model, which it might be already getting pretty good at.
I mean, it'll build you a tree, and you'll get a reasonable result. It knows how to do that. It knows how to do the tuning for you, but it's still going to build you the model. And that's the key, is that you want a deterministic model. So the same person with the same set of properties will end up in the same place each time, as opposed to sometimes they'll be here, sometimes they'll be there, because if you ran it 100 times, you'd hit that 1%. You don't ever want that to actually happen.
Yeah, what I keep telling people is that I think, to your point, Priyanka, there is a lot of value in asking an LLM to describe, okay, how should I do this, and maybe help me build this system as well. But once the agent or once the LLM system has built that system for you, maybe there's no need to ask it to continue to think about how to build this again and again. That's where maybe let it go for the first time, and then maybe freeze it. If it works, freeze that, make that as a deterministic system, which requires maybe an ML model, or which doesn't require any other non-deterministic model at all.
So what you're
So
saying,
yeah.
actually, if it ended up doing, if actually it ended up, for example, asked to build a churn model, or a server downtime model, I don't know, and it actually creates perhaps on the back end it is using a lasso regression. I mean, for the lack of it will use lasso regression and build your regression model. You're just saying take the output of a regression model versus having it kind of run as a LLM, which is a fair point. I just haven't actually, personally, I haven't used, since we have been building models for, I don't know, 20 years in a different way. I haven't yet actually used any LLM. We haven't used Claude or Gemini or anything else to build one of our machine learning models. Have you guys used it? And what? Yeah.
Because it's super fast, right? Like I can never remember the syntax for XGBoost, because XGBoost isn't an sklearn. It uses a slightly different syntax. So I can never remember, like, do I call dot model on it? Like, how does that output? But I know to tell it to just like build the model that I want. So that part is really easy. And then if you want to build something to like run through a bunch of hyperparameter tuning, that's super easy also, because it's like, well, there's 4 main hyperparameters that I might want to tune, so I can just do this as 4 loops. But do I really want to go through all combinations? And your LLM will probably tell you, like, yeah, you probably don't want to do that. Here's some guidelines. Here's the ones you want to run through, and then do all combinations of these things. It gets 5 to 10 lines of total code, and which also makes it really easy to check. But where I'd want to look at things as a human is, am I splitting my data correctly?
Yeah.
Are these actually the features that I want to bring in?
Yeah.
And you can ask for things like, oh, did I accidentally like have some feature injection that I didn't want there, where like I've got my target where it shouldn't be, or I've got something that actually represents the target that I don't want to have representing it in the independent data set. But aside from that, the LLM great at writing the code for the model, because model code's generally really simple.
What I have a pushback on that, Shanti. I think the big power, at least from the models, so we are behind the, and I may have shared this, the 7-Eleven ATMs, that cash loading mechanism is our model. It was a pretty sophisticated, highly sophisticated model. I think the biggest power we got in that model, and many other models as feature engineering, like really understand what's happening on a weekly basis in an ATM, what kind of behavior happens at an ATM in a weekly basis, what happens Friday night, what happens Saturday, at 5 p.m. And those, so feature engineering is a big deal for core machine learning from my perspective. Not only like I call it broadly feature engineering, but really doing, I mean, the data is never perfect. Like, for example, if I go back to ATM out of cash, it's zero, but actually the demand is not zero, but the value is zero. You know what I mean? Like the cash taken out is zero because the machine is out of cash. So you really need to actually do some kind of modeling prior to do imputation and then do your second level. So that kind of sophisticated um, machine learning, like sophisticated feature engineering, is actually coming out of human context. It is not coming out of broad understanding. So I doubt that LLM can do that. Although
They're much worse. They're much worse at that. I don't generally want LLMs to do feature engineering on their own. They can do some of it. They'll, find you some, like, you can say, give me all the two-way, three-way interactions, tell it some cutting, but you definitely want to have a lot of human input there, because that's the actual value of data scientists, is building a contextual understanding of this data so that you can derive some non-obvious relationships which don't exist in individual variables, right? You're looking for, well, these things interact with each other, but only at certain times. So it's an odd combination that's hard to find by just doing some multiplication. The LLM will do a bunch of that search for you, and it'll tell you, like, yeah, you should probably cut this into categories, which is always kind of interesting.
Yeah.
But
Yeah,
you're still
I
going to want to
think
apply human intuition.
Yeah, I think the way I see it is that there is definitely a lot of scope for using an LLM as an accelerator for a human developer. So in this case, like Shanti mentioned, right, the um, a data scientist is wanting to build a model, and it has the coding copilot on the same screen, and it's sort of having a full blown discussion with the copilot about, help me, how should I think about this, here's what I think, and the LLM will create a nice plan. The coding copilot will create a nice plan and architecture that this is how I think you should go about it. And then sometimes I have engaged in like full blown debates, because it can get really assertive and opinionated, and I'm like, I think you're wrong, and then of course it's
You're
very
right.
yeah, oh, my bad, I'm sorry. So it's important to have that, but it does make the process of, in this case, you have to build a training pipeline and you have to build an inference pipeline. Now, you don't need to train that model every single week, or if you do, you don't need to change your training pipeline every single week. I think that's the data science world that we lived in. So how do you get to that pipeline of training and inference at a speed which was sort of unthinkable pre LLM? I think that's where it has played a big role. And once you have that pipeline, stick to that. I mean, if it works, stick to that. No need to make that pipeline non-deterministic, because that's where people are like, let's have an agent, and that agent can figure out what needs to be done. And I'm like, sure, for the first time, that'll accelerate you,
Yeah.
but you don't need to rebuild the whole
Yeah.
pipeline every single time in all cases. In
Yeah.
fact, there are very few cases that you might need to do this. So that's
Yeah.
the piece that I stress about a lot.
Yeah, actually, like a year ago, we used to tell people, we build the model, then you just make the model available as a tool to whatever your agent is doing. So it calls the model when it needs to know what's the prediction for this thing. These things
Hmm.
can live very nicely together.
Yeah.
So the model is built and like it's sitting in a Python code versus it's sitting in a resubmitting of the prompt to LLM. I think it's
Oh, yeah,
Exactly.
absolutely. Like, yeah, don't reinvent the actual model, because you also, at that point, would never end up hitting the exact same like hyperparameters and other pieces. Like, you want those to be frozen so that you can compare them when you want to change them, but also when you run things through the pipeline, be able to prove that I ran this through, I got this output, and that's always going to be the case. Otherwise, you would go to like finance and some of the other applications, and you can no longer use those models if you can't get one set of inputs to a single output.
That's exactly right. Let's talk about, like, I know we took a little bit of a sidestep on machine learning and using LLMs for machine learning models or creating machine learning models, but let's talk about the foundation architecture. Anshul, I understand that you guys have harnesses or a harness or many harnesses. and you're calling different APIs, different LLMs. Talk to me about architecture. How are you guys thinking about architecture? Actually, let's talk about architecture, because then I think means different things to different people nowadays in terms of LLM.
Yeah, I think, I mean, so like the term that we like to use is like agentic architecture, right? What makes an architecture an agentic architecture?
Yeah.
Because there are pipelines in any, let's say in any workflow, let's say in a pipeline, there are 10 different nodes, and one node uses a machine learning model for an input, machine learning model, output. And then another node, let's say step number 7, uses a large language model to, again, create an output. Like that to me is a standard system pipeline which uses a large language model and a machine learning model potentially, right? So to me, I mean, a lot of people also call that as an agentic architecture, which is, I think, it's a stretch in my opinion. There's a whole debate about what is an agentic architecture or not, but like in my opinion, the agentic architecture is more like you have an input, which is a pretty standard goal that, okay, I want you to make a meal for me or something. Like an agent is like, it gets a very high level goal, and then the agent has to decide what is the path that I need to take to solve this problem. And then so there's a workflow determination aspect of it, and that workflow determination might be, hey, I need to call this tool, I need to call another agent. And if that's happening, great, that is an agent. And then at the end, once you have done that, there's also a component for evaluating the output. Like once I have called these 3 tools and one additional agent to solve this problem that I've been given, I have gotten the information that I need, I have processed that information, and now I have an output. And now I need to verify if that output actually makes sense or not. So there's an eval loop as well. So I'm verifying the output, and then if it is not good, I send it back to my processor, like the reasoning engine, which is an LLM based node, to figure out, okay, this actually doesn't make sense. So I need to do something. For example, going back to the use case that I talked about, where if a software application goes down and you're looking at logs. So let's say if you have built a system which looks at logs and tries to determine what's going wrong,
Right.
it will figure out, it will have some understanding of what's happening in the logs, but maybe at the end it's like comes back with a reasoning that this is what's gone wrong, and then there's an eval check, and that tells you that, okay, actually it doesn't make sense. So it's like, okay, I'm going to try again, and then go through that process until I am satisfied at that eval. So that is the overall like agentic architecture, where it creates a non-deterministic workflow, number one, and number two, it also has a step for self
Validation.
assess
Yeah.
self evaluation and iteration. Yeah.
Shanti, how do you think about architecture?
So I think about the different patterns that we want both the agents to follow and how the agents are going to communicate, know that they're done, and kind of break out of agentic loops or agentic graphs, right? So there's a couple different thoughts about this. Like, I mean, a loop is just a fancy graph to begin with anyway. Right? It's a single type of graph. It's cyclic instead of acyclic. Uh, but when I think about what that's going to look like, it's, do I have an orchestrator that's like my smart agent that's delegating out tasks, which then come back to it, and that orchestrator can make some determination?
Yep.
Or so we were recently at the Anthropic base camp, and they were talking about a different way of thinking about that, which is you have your worker agent that's just out there doing its thing, and when it stops and realizes it needs help, actually reaches out to a smarter model and says, "Oh, can you help me now?" I was like, "Well, that's an interesting way of looking at it. It's actually much less expensive and more token efficient to build that type of agentic architecture." So that was kind of interesting. But usually I think about it in the former, which is there's some sort of orchestration agent that we have a graph of things that might need to happen. The agents within that have a goal that they're trying to achieve. They think they've achieved that goal. They have some self checks, and then the orchestrator will look at whatever it thinks is the final work of that and just say, yep, that's good. I can send that over to another node. Or we'll say, like, nope, keep going, or go back to it. So I usually think about the architecture itself as some sort of graph network, and then there being some controlling agent that's pretty much always running, trying to think through, is this right? What should happen? Where am I sending this next?
Got it. Yeah, I think that makes sense. Both of what you said is very similar along the line of uh, something which is having an overlook orchestrator, and then there is a bit of nodes and pipelines having an input and output, and how you're thinking about it. I like this idea of going, and especially because it now leads us to the next topic which we want to talk about is our token optimization, which is have the agent also look for look for additional help. That's going to be interesting. How an agent itself says, I have reached the limit, let me go and call into a higher or a thinking mode or a higher model. Um, but yeah, let's talk about token optimization. I know, Shanti, we started with this call with a big faux pas that you were talking about. Maybe we start with that story.
Yeah, Piyanka, one of the things we were doing is we had a classification task running, and it's running hundreds of thousands, which should be no big deal. It's taking a look at a post and saying, is this positive sentiment, negative sentiment, neutral sentiment? And it's only producing one output token, or maybe it's 4 output tokens to hold that word. Whatever. It should be very cheap, right? I should be looking at 1 million, maybe 2 million total output tokens. I'm using a mini model, paying a couple of bucks, no big deal. We see that we ran out of money on this particular API key. How'd we hit our budget so quickly? Doing the debugging, it's like, oh, it's a reasoning model and thinking is still turned on. Well, when thinking's turned on, we're burning an extra like 1,200 tokens per call to do this super simple task. Now, why is GPT-5.4 Mini a thinking model? And to begin with, because all of the new 5 models are thinking models. So neither here nor there, but that's slightly annoying. But also lets you know that if you pick the wrong model for the task, or you've been using the right model in the wrong mode, you can burn way more tokens than you expect to, maybe 1,000 times more tokens than you think you're burning. And that's a real problem for businesses, thinking about how to be token efficient, or really it's dollar efficient, just a new way of thinking about your dollars. Another thing we were talking about at that Anthropic base camp was around, from an enterprise perspective, on the development side, a lot of us start with Opus. Like, we start with the high-end models because we just want this thing to work. They talk about start with the lowest model you have access to and only move on when it's not working, for a couple of reasons. One, Opus and Opus class models will make up for your bad prompts. They can infer what you were actually trying to do. So you don't have to write great prompts. Opus will figure it out for you. Haiku does not do as good a job as figuring out your prompt, but if you were to spend a little bit of time figuring it out, you might be able to use a model that's 1/3, 1/5 the price by putting a little more work in up front. And not enough companies that are trying to control cost long run and the long term are actually doing that. So starting with lower end models and only moving up when you need to. And there's interesting points where high thinking in some models will cross over with mid or low thinking on a more powerful model. So actually testing all of those different levels. So it's like, okay, I've got 3 models and 6 levels, means there might be 18 things that I need to test. And almost nobody's running through all of that evaluation when they should be.
But it's also, I mean, the thing is that evaluation time is almost wasted because 5 days later, it's all changed again. So you thought you did a pilot and now you put it into production, thinking this is the model of choice, which we are doing the same. We have 200 nodes for Enola,
Yeah.
and but what wins today doesn't win tomorrow. Or
That's why you need a good eval harness where you can just drop the next one in and run it through, keep
Yep.
track of where you were. Like, you need something where you actually have some scoring, because every time you should be saying, what is the smallest, cheapest, fastest model I can use to accomplish this goal? We know the big one will do it. How low can I go? Like the limbo.
yeah, yeah,
Yeah, I think the point about eval harness is like the key point here. I have been like I have been like so vocal and opinionated about this in my own company that everyone needs to be focused on investing in building a strong eval harness and eval data sets right at the start, because it will help with problems exactly like this. Not only with just the cost, but also like the overall quality of your application. But also whenever something new comes up, it's just a matter of plugging in that new model and seeing what happens with that new model. And presumably if it's a cheaper model, you can maybe spend less money, and maybe if your eval scores are not getting affected, just do it, just move. But if you don't have that, that's a big, you need to figure out like how do you decide whether this needs to be done or not. And then that becomes like some VP tries that model and basically sees good results, and then like, hey, I think you should be using this model. It becomes a very subjective uh,
Yeah.
problem,
And
which
if you guys haven't seen the newest DeepSeek V4 stats, this has completely upended how everybody should be thinking about models. It is so cheap and so good. It is like off the charts on its own in terms of like cost per task run at like 18 cents to complete a task versus other models that are $1 plus.
Yeah.
And
Yeah.
it's just really good. And it's small. It's 304 billion parameters in this new version. It went from 284 to 304. That is small enough that you can host that on single GPU. I mean, like an A300 single GPU. Businesses need to start taking that very seriously. Like it's very reasonable to use and to think about.
Have you started? Have you guys moved over to DC?
I'm only 73% done with the download. So
Yeah, there is a general there's a general I mean, I don't know if it's still in the market, but people do have apprehension about non like I don't know if it's still for DeepSeek or for
Yeah, I mean, open weight models coming from China. Yeah, I think big enterprises are still sort of wary of it for political, I think political reasons. But I think open source models are going to be, I think, the future. I mean, I know it comes with some overhead of managing infrastructure by ourselves,
Yeah.
but a lot of these big companies have infrastructure already in place, and it's just sitting around. So you kind of have to, both in terms of compute and human resources. So like, how do you make best use of it? With the rising costs of tokens, I think that's a real strategic shift that is going to happen.
It only takes a few of those $1 million per month token bills before you start going, maybe the politics aren't as important as keeping this business
That's
healthy.
right.
Yeah, and we also a few episodes ago we did talk about the smaller parameters or whatever they call it, smaller LLMs, which maybe less than, what was the definition? Less than a billion? What was the definition of smaller parameter? I don't know.
Oh, I don't even know anymore.
I don't think there's any formal definition. I think it's like
Smallest.
generally if it's less than 10 billion parameters, I have seen people calling it SLMs,
Yeah.
but I don't think there's like a formal definition for that.
Yeah. And basically whatever you can run in your own system, that could be a small and that could be. So do you guys see and this is the sort of the last thing I want to talk about. Okay, so just summarizing in terms of token optimization, what I heard today was like, can you do this task? Think about eval harness and always having it, but can you do what you're trying to do is, can you do a task at with the lowest model? What do you call it? Lowest model or
Cheapest.
well, it's cheap, but it's also like I don't know, thinking categories. Is there a formal name for like these models which have less ability versus more sophisticated model? I don't know, but basically you're looking for the smallest model to solve your problem before you move on to the other one. And eval harness is a good way of thinking about it, especially for something which is going in production. Like you have a system which is a customer support agent. It's on all the time, 24/7. You're building on it. You're making it better, thinking about what model it should run on and what's the cost, I guess. So so moving on to the last piece of it, which is do you see the future as more and more people bringing in the localized, basically bringing in the models and running it on prem versus continuing to do API calls? Very expensive. Sometimes it burns through your monthly budget in a day. I mean, that's a huge question, which if you bring it on prem, then it's all in your control, and you're kind of running your costs. How do you guys think about it?
I think more companies are going to take a much more serious look at AI sovereignty. They want to own more of this. Nobody wants to be at the whim of another company. And that's how it feels when models can get pulled away from you that you might have started building business process around. But also, the next generation model might not be better or might break stuff you built. You own the model, you own the weights, you freeze them anytime you want. you get to control that upgrade process. If you're a large enough company where you have very serious business process, this starts to make a ton of sense.
Yeah, I think rising token costs and the token intensity behind the scenes of new models and the significantly improving quality of open source models, I think those two factors, if you combine, are forcing the companies, like, to start already talking about this shift from, okay, how do we get more in control, because these bills are not, we are not in control of them, and companies like to be in control of their finances. um,
Yeah.
so even it might slow things down maybe to some degree, as far as like adoption goes, but I think that might be the future.
Yeah, yeah, I can see how that might be. And then would that mean that these frontier models are overpriced? The companies are overpriced. Uh, but like before we end, Shanti, 2 or 3 takeaways. Anshul, 2 or 3 takeaways from today's conversation.
Yeah, I mean, think about how your agent is running, not just like what their goal is, but also how efficient is it at achieving that goal. And there are things you can do to make it more efficient.
It's like, and in that spirit, following up, building on Shanti's comment, is like, you can focus on eval harnesses, prioritize and invest in that, not only for after you are in production, but even while you're developing systems, because that's when it matters as well. Which also helps with model selection. So how, if you can build a capability, or there are some open source capabilities out there which can help you with selecting what's the most cost optimal and high quality model that can be good enough for use case, use it, like focus on that. And again, agentic architectures are good. Use it when you truly have a non-deterministic workflow need. If you don't, use it as an accelerator to set it up. But once you have set it up initially, stick with it. That's helpful both from a cost standpoint as well as from a reliability standpoint.
Great. And my 2 takeaways, I think, just keeping an eye on the future, thinking about bringing in these open source models, or beginning to start thinking about it. Thinking also from setting up not only eval harness and harness as well, because you want to have that choice between models and API calls you're making, for even one task. When you want to, you might be wanting to call a Gemini model versus a an Anthropic model in different cases. So having harness here, having eval harness, and thinking about how you can start building and bringing in open source models for greater control and potentially cost optimization in future. Which at present time, when you have to invest in servers and server spaces, might look like cost, but maybe it's in the long run, if you set it up in a more controlled fashion, that might pay off. So great. This is a great, good conversation, good topic. Thank you, Shanti. Thank you, Anshul.
Yeah, a lot of fun.
Thank you, Piyanka.